Hello, everybody. Greeting and welcome to our Mathematic Olympiadia. In this episode, we are gonna take two rightmost digits of this huge number, 2025 to the power of 2025. It means that 2025 gonna multiply by itself by 2024. How to get this number and get to right most of digits and take it in this episode. In this episode, we are gonna take a method to get these two numbers. So until the end of the video, stay tuned and get to the our question. Our question is, what are two rightmost of this huge number? 2025 to the power of 2025. So, if you pay attention more precisely, the two rightmost of the both number is 25. So we know that 25 is some specification that 25 times itself gets 625. So by knowing this, we can reach to the method that get to rightmost of this number. So first of all, let's expand this power. 2025 to the power of 2025. It means that 2025 of number of 2025 gonna multiply by itself. So we can write them as below. 2025 cross 2025 cross until cross 2025 for 2025 times. And then we can write these as a huge number and get to rightmost of digits. So how to get that? We can use of the binomial theorem. So the binomial theorem says that we can write 2025 as 2000 plus 25, all this number to the power of 2025. So we'll separate the number into two separate number. 2000 has a factor of 100 and 25 is the ones and tens of numbers. So binomial theorem says that if you gonna power of two statements such as 200, 2000 and 25 to the power of integer number such as 2025, we just need to power of the statement by this pattern. So the pattern says that it is the sigma of 2000 to the power of I cross 25 to the power of 2025 minus I and the chosen of I from 2025. And the index starts from 0 until 2025 and maximum it has 2026 statements. So if you pay more precisely, we need only two digits of the right number. And if the number has a factor of 100, it means that two rightmost digit is equal to 0. So we can find the factor of 100 and separate it and then get the number which don't has the factor of 100 and only calculate those number who didn't have the 100 factor. So we can write the summation as the sigma of I is equal 1, the chosen of I from 2025 cross 2000 to the power of I cross 25 to the power of 2025 minus I plus 25 to the power of 2025. And that last term is for the I is equal to 0. Because if I is equal to 0, the chosen term is equal to 1, 2000 to the power of 0 is equal to 1, and 25 to the power of 2025 minus I is equal to only 25 to the power of 2025. And we can separate these factors into two terms. One of them has the factor of 100 and the other don't have the factor of 100. So the left term has the factor of 100 because 2000 have a factor of 100 and all the power is bigger or equal than 1. So A is divisible by 100. And then A is equal to 100 times A. A is an arbitrary number. So then we can write the whole number as A plus B, which A is equal to 100 times A plus B. And we just need to get the B factor. So here we can calculate B factor. 25 to the power of 2025. We can write the sentence of 25 to the power of 1, 25 to the power of 2, and 25 to the power of 3, etc. until 25 to the power of 2025. We can get two rightmost digits of this number. 25 to the power of 1 is equal to 25. So the rightmost of this number is 25. 25 to the power of 2 is equal to 625. And the rightmost of the number is 25. 25 to the power of 3, which means 625 cross 25 is equal to 15,625, which has two rightmost of number is equal to 25. We can guess that 25 to the power of 2025 has two rightmost digits is equal to 25. But we can prove the statement. The statement says 25 to the power of n has two rightmost is equal to 25, which n is an integer number bigger or equal to 1. So we need to prove this proposition. So it is a proposition. The method to prove this proposition is using mathematical induction, and this is a way to prove the statement level by level. So first of all, 25 to the power of 1 has two rightmost of digits is equal to 25. So the first condition is proved. And the second condition, if 25 to the power of small n has two rightmost digits is equal to 25, we want to reach the statement that 25 to the power of n plus 1 has also two rightmost digits as 25. So 25 to the power of n can written as 100m plus 25. And 25 to the power of n plus 1 is equal to 25 cross 25 to the power of n, which is 25 times 100n plus 25. We can multiply 25 to any part of 100m plus 25. We can distribute 25 to the parentheses and get 2500m plus 625, or 2500m plus 600 plus 25, which is equal to 100 times 25m plus 6 plus 25. 100 times 25m plus 6 is divisible by 100. So the two rightmost of the number is equal to 25. So the proposition has been proved. 25 to the power of n has two rightmost digits as 25. So then 25 to the power of 2025 also has two rightmost digits as 25. So we can lead to the number of 25. 2025 to the power of 2025 leads to 5 as two rightmost digit number as 25. Okay, we end the video. I hope you all enjoy from this video, and until the next video, have fun, stay tuned, and goodbye.